Now this is the recent PYQ friction question. So he has asked the value of mu. How to find the value of mu? No worries. By force balance we can find the value of mu. First, one important thing, the norm of force acts perpendicular to this plane. If the body was like this, if here the body is like this, so normal will act here. If the body was like this, normal is perpendicular to the surface and not to the body. सरफेस के परपेंडिकुलर नॉर्मल काम करता है. जैसे कि सपोज अ बॉडी इज लाइक ऐसे रखी हुई है, टंगी हुई है, इस तरह से नॉर्मल ऐसे जाएगा. सो हियर नॉर्मल का डायरेक्शन ऐसे, 750 का डायरेक्शन ऐसे, 900 का डायरेक्शन ऐसे, म्यू एन का डायरेक्शन ऐसे, क्योंकि म्यू एन इज along the surface. Now find every angle. You can find the value of mu. Okay, the second question is this. Here the concept of trust was really important. Why was it important? So how was it important is the concept of trust was really important here. How? He said that at 90 degree, this is not just at 90 degree, it will just start. So consider this angle as 90. After this, the body is going to be just start. The force will be still F. Now analyze the joint this F. You can find the value of this, and it comes out to be I think negative. Negative means it is compressive. And how does a compressive looks like? It looks like this, and here it looks like this. So, and here both are compressive, so here it will look like this, and here it look like this. So P joint, on P joint one force is here, one is normal and one is mu n. Now analyze the point joint P. At joint P, just summation of f, y and x is equal to 0. You will find the value of mu. And here similarly, Q joint is here. There is one compressive force was here. There is one normal, and there is friction. Okay, sorry. Friction will be here because it will try to move here. So friction will be here, and here friction will be here. Yeah, you can see the friction will be here. So I have absolutely solved the question correctly. And this is one more question which I'm not going to solve first of all, because there is some angular momentum problem here, because impulse is there, so impulse causes change in momentum. Okay, don't worry, I don't care about this. Here due to roller there will be y direction force due to this hinge. First of all, the problem is with roller only. Roller acts perpendicular only. For hinge it is always here and here. If a hinge was like this also, it will be still here, because it restricts the motion in y and x direction. Roller restricts motion in the direction perpendicular to it, perpendicular to the rollers. So for hinge it will look like this still only, and this is the center. So moment about center of gravity of all the forces is equal to 0. And one more, force F, because consider this as equilibrium system, so Fy on the system is equal to 0, and summation of Fx on the system is equal to 0, and this force is F. So you will find the value of the F. weight is given, so you can find it. Weight is given, so weight will act here. It won't participate in moment, but it will participate in here. So from here you can solve. You can just get a basic idea. If this type of question arrives in a paper, then you may be able to solve this question. And the last topic of this is Lagrangian L. Lagrangian L. What is L? Which was asked in GT 21. This was the question in which Lagrangian L is asked. Okay, Lagrangian equation, only L will be asked. What is L? L is equal to total kinetic energy minus total potential energy of the system. So here, suppose if there was just a spring mass system, and if it deflects by, and it has a velocity x naught, what will be total kinetic energy? Half mv square, because spring does not have any kinetic energy, it has only potential energy, minus total potential energy, half kx square. So this was Lagrangian of this system. So for this question, there is a spring, so minus half kx square will appear somewhere. It appears here, appears here, so you cannot eliminate the options. And there's a mass with velocity x, so half plus half mv square should come. So plus half mv square, half mv square, half mv square, mv square. So you cannot cut the options. So basically I was telling you how to cut the options if possible, and if not possible, this question cannot be solved. You cannot solve that question, no one can. Now one more important thing, there is two things like total energy balance and total momentum balance. Total energy can only be balanced when there is no friction or in elastic collision, when there is no loss. But momentum balance, i.e. initial momentum is equal to final momentum, initial momentum of the system is equal to final momentum of the system, can be applied anywhere, even in non-elastic collision, even in friction. The only problem is when there is no equilibrium, it cannot be applied. But in mechanics, we study only equilibrium cases. So momentum equation can be applied anywhere. But for applying energy equation, you have to see if अगर फ्रिक्शन होगी तो डोंट अप्लाई, अगर नॉन इलास्टिक कोलिजन है तो डोंट अप्लाई. और इलास्टिक कोलिजन क्या होता है? कुछ नहीं. ओके, आई डोंट नो. थैंक यू.